Today is Sunday, April 12th, 2026. Yeah, you see from my previous live, I still have this up. Which means I went live about a few minutes ago. Okay. I bet my one class spot who got 1.2 million. 1 point. Okay. Sorry that noise is bothering me. Okay. So, today we're going to be finishing our lesson off of examples 2 and 3. Well, not 2 and 3, 4 and 5. Which is our word problems. So you see, on Saturday when I went live, I taught my students lesson 6-2, examples 1, 2, and 3. But today, I'll be teaching examples 4 and 5. But that's going to be for part-time. But the rest of the class, my students are going to be doing a lesson 6-2 worksheet. I did not know if they already did their lesson 6-2 vocabulary test, but I'll make sure that they get that before the worksheet, okay? Okay. So, we're already 2 minutes to class, okay? So, my thing dried up. So, lesson 6-2, examples 4 and 5, let's get going. What's 62? 6-2. I think that was live 8. Radicals and national exponents. This is live 12. Okay. So, let's get going. Okay. So I think I might be receiving some live comments in a little bit. Anyways, so let's get going before I see the comments. So, example 4. It says solving a real life problem. So solving a real life problem. Example 4 says, understand a problem. Okay. No. The radius of R of a sphere is given by the equation R is equal to this, where V is the volume of the sphere. So the equation, I think you all might want to watch out for this, is R 3V divided by 4 pi this to a power of 1/3. What's this? Kevin X. Hi. Okay. What the? Thanks for the help with the math. Yep. Wait, I'm not ending the live stream. If you're going to be watching the rest of the video, you might want to pay attention. Speaking of which, if you're in grades 9 or 10, then I could certainly teach you in a helpful manner. Thank you. Okay. Where B is the volume of the sphere. Find the radius of a beach ball to the nearest foot. Use 3.14 for pi. Well, instead of 3.14, I'm just going to use 3.14. Are you in college? No! No. No, I'm not in college. Yeah, I'm not in college. I'm in 9th grade. I have a special memory where I could teach middle school and high school math, including grades 7, 8, 9, 10, 11, and not 12. So, yes, high school. I'm in high school. Freshman. So, I could practically teach myself. So, speaking of which, we are given that from you. Okay. And then the thing said 113 cubic feet. Oh. That's what I was saying. This equals 3 to the power 113 divided by 4 times 3.14159. But we're just going to use 3.14 anyways. Because I know the first 100 digits of pi. 200, actually. Sorry, I have to go for my treatment. Bye. Bye. Yeah. Okay. So, yeah, now it's stating 339 divided by 12.56. Right. I was forgetting something. 1 over 3, 1 over 3. And then it was saying it was approximately equal to 3. But let's see what it's actually equal to. So, okay, 339 divided by 12.56 to the power of 1 over 3. Here is the final answer according to my calculations. So it's 2.999646101. You don't believe me? Go check it out for yourself. So let's approximately equal to 3. Okay. So so look back. To check the answer is reasonable, compare the size of a ball to the size of a woman pushing a ball. The ball appears to be slightly taller than a woman. The average height for a woman is between 5 and 6 feet, so a radius of 3 feet or a height of 6 feet seems reasonable for a beach ball. Just stating this is really a word application problem. Why on earth? Okay, so never mind. Why is the beach ball normally taller than the woman? So, like, stating this, I'm like 5 foot. Wait, not 5 foot. 6 foot. Between 6 foot and 6'1" now. So speaking of which, I could originally grow. Okay, so, well, it states that a radius of 3 feet or height of 6 feet is reasonable for the ball. Well, in this case, normally. My beach balls are normally like up to like around Here, I think? I don't know. I don't have one yet. So, okay. Okay. So now we're talking inflation rates. For example, for 5. For example, 5. So, we have 45 minutes left of class. Yes, I've been online for 10 minutes, 40 seconds. And I already seem to have 5 tracks. So, okay. So, yes, I know. We have only one more example left before I have to give my class some instructions. I'm gonna go live doing that. But we'll see. So, okay. So, now we're going to be talking about the inflation rate. So here is a surprising formula that I have never seen before. This is my final live today. Maybe. So, it says to calculate the annual inflation rate R in decimal form of an item that increases in value from P to F over a period of n years, you could use the equation R equals F over P to the power of 1 over n minus 1. That's the formula. So find the annual inflation rate to the nearest 10. The product of a house that increases the value from $200,000 to $235,000 over a period of 5 years. So now we seem to have a problem. So now we have 235,000, which is F, divide that by 200,000, which is P, of 1 divided by 5 minus 1. That seems a lot for a house. Single house. So, speaking of which, so now we're going to divide. So it's equal to 1.175 times, multiply that to the power of 1 divided by 5 minus 1. Well, 1.175, wait, why did I put 4 or 5? 7. 5 times to the power of 1 divided by 5. 1.032779415. So that'll be 1.03 278. Because I'm rounding that up. Minus 1 is approximately equal to 0.03278. Or 779,415. So the annual inflation rate. Okay, so you're gonna have to move this 2 decimal places to the right. So now the annual inflation rate is 3.28%. is approximately 3.28%. That's expensive for a house. So, okay. So, here is what I'm going to have you to do, class. Not talking to the people that are watching this video right now. Okay. So, you are going to do problems 1 through 30. Well, 1, 2, 1 to 34, 37 to 40, 37 to 44, and that's it. So, to the people that are watching this video, thanks so much for watching this lesson. This is the final day of our lesson 6-2 lesson. So, if you have time learning, comment down below that you had fun learning, and please like and subscribe. Bye.